The cat sat on the what? A language model has to guess the next word. It scores every possible word and ranks them by probability. The word mat wins with the highest probability. Drop it in, and the sentence completes itself. That's next word prediction, the engine behind every language model. Now the sentence is a row of ID numbers, but an ID like token number 93084 carries no meaning on its own. It is just an address. The number for cat is no closer to dog than to refrigerator. We need something richer. So each token ID is used to look up a vector, a long list of numbers, maybe a few hundred or a few thousand of them. This vector is called an embedding, and think of it as a set of coordinates placing the token somewhere in a vast space of meaning. Here is the beautiful part. During training, the model learns to place these vectors so that words used in similar ways end up near each other. Cat and dog drift close together. Cat and refrigerator end up far apart. Meaning becomes geometry. These directions in space can capture strikingly abstract relationships. The famous example, the step from king to queen, points in roughly the same direction as man to woman. The model was never told about gender. It discovered that structure just from reading. There is one more thing to add before we go deeper. So far each token knows what it is, but not where it sits in the sentence. Order matters enormously. Dog bites man is not man bites dog, so the model mixes in positional information, tagging each vector with its place in the sequence. Now we have a stack of vectors, one per token, each encoding both meaning and position. This stack is the raw material the model will refine. Everything up to here was just preparation. Now the real thinking begins. The vectors flow into a tall tower of processing layers, stacked one on top of another, sometimes dozens, sometimes over 100. Each layer takes the vectors it receives and hands back an improved version of the same shape, same number of vectors in, same number out, but better informed. What does better informed mean? At the start, each token vector only knows about itself. The whole job of the layers is to let tokens look at each other, so that by the top, every vector is soaked in context from the entire sentence. The key mechanism that lets tokens share information is called attention. The name is apt. At each step, every token gets to look back over the others and decide which ones are worth paying attention to. Think about the word it in a sentence. To understand it, the model has to figure out what it refers to. Attention is how the vector for it reaches back, finds the noun it stands for, and pulls that meaning into itself. Attention works by having each token ask a question and every token offer a key, like an answer it advertises. When a token's question matches another's key, attention flows strongly between them, and the matching token's information is copied over. It is a learned, content-based lookup, done for every token at once. And there is not just one attention operation per layer. There are many running in parallel, called heads. One head might track grammar, another might follow which words describe which, another might match quotation marks. Together they read the sentence from many angles at once. After tokens have gathered context through attention, each vector passes through a second stage, a small feed-forward network. If attention is about tokens talking to each other, this stage is each token thinking on its own, transforming what it has gathered into something more useful. This is where much of the model's stored knowledge lives. Trained on mountains of text, these feed-forward layers act like a vast learned memory, nudging each vector based on patterns seen countless times. Facts, associations, habits of language, they are baked into these weights. Attention then feed forward, attention then feed forward. This pair repeats up the entire stack. Each pass lets meaning propagate a little further and grow a little more refined. Low layers catch surface patterns, high layers assemble genuine understanding of the sentence. One subtle but crucial rule: when predicting the next token, each position is only allowed to look backward, never forward. The model must guess what comes next using only what came before, exactly as it will when writing for real. It never gets to peek at the answer. Now we reach the top of the tower. For predicting the next word, there is one vector that matters most, the one sitting at the very last position, over the final token before the blank. It has absorbed the whole sentence and now carries the model's compressed understanding of everything read so far. This single vector is the pivot of the whole machine. Hundreds of layers of processing have poured into it, but it is still just a list of numbers, a point in meaning space. Somehow we have to turn this one point into a guess spread across every word in the vocabulary. Enter the output matrix, sometimes called the unembedding. Picture an enormous table, one row for every single token in the vocabulary, and each row is itself a vector living in the same space as our hidden vector. 50,000 rows, one per possible next word. To score each candidate word, the model compares the final hidden vector against every row of this matrix. The comparison is a dot product, which is really just a measure of alignment. How much do these two vectors point the same way? The intuition is simple. If a word's row points in nearly the same direction as our hidden vector, they are well aligned and that word gets a high score. If it points a different way, the score is low. The hidden vector is essentially asking each word, how much do you look like what I expect next? Do this for every row and you get one number per vocabulary word, a whole array of raw scores. These raw scores have a name, logits. There is one logit for every possible next token, tens of thousands of them, but logits are awkward to work with. They can be large or small, positive or negative, and they do not add up to anything meaningful. A logit of 8 for Matt does not by itself tell you the chance of Matt. We want honest probabilities, numbers between 0 and 1 that sum to 100%. The tool that fixes this is called Softmax. It takes the whole array of logics and squashes it into a proper probability distribution. Every output becomes positive, and all of them together sum to exactly 1. Because here is the crucial move, that freshly chosen word is now appended to the input. The sentence just got one token longer, and the model simply asks its one and only question again. Given the cat sat on the mat, what comes next? So the whole pipeline runs again, top to bottom. Tokens to vectors, up through the layers, out through the output matrix, softmax, sample. A new distribution, a new word chosen, perhaps and or a period. Then that word is appended to, and the loop turns once more. Watch it run. One token at a time, the model literally writes. Each new word becomes part of the question for the next word, so the sentence grows by feeding on itself, guess after guess after guess. This is why long outputs stay coherent. Every single prediction sees the entire text so far, including everything the model itself just wrote. It is not planning the whole paragraph in advance. It is staying consistent by always conditioning on the growing history. And it is also why models sometimes drift or repeat or confidently say something false. There is no fact checker inside, no ledger of truth. There is only that distribution over next tokens shaped by patterns in training data. Fluent and wrong can look, to the machine, exactly like fluent and right. Step back and take in the whole machine at once. Text becomes tokens, tokens become vectors. The vectors climb a tall stack of attention and feed forward layers, gathering context, until one final hidden vector emerges. The output matrix turns it into a logit per word, Softmax turns logits into probabilities, and we sample one word. And then the loop. Append the word, ask again. That is the entire engine behind every essay, every answer, every conversation you have ever had with one of these systems. Staggering capability, built from one relentlessly repeated question, what comes next, what comes next, what comes next? If this made it click, subscribe for more visual math.